The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Welcome back, children. So, previous two classes we were discussing about the specific patterns that exist in modern periodic table, right? These specific patterns actually are valuable tools to study or to predict about a particular element. These are called trends. What are trends? Actually, we do follow trends in our life, right? According to season, right? So, trends are actually the changes in properties as we travel across a group and as well as a period. These changes are called as trends. These are the trends we were discussing in the past two classes, right? What were the different trends we discussed? The first one was atomic size. What was the trend of atomic size down a group and across a period? I hope you remember, as we travel down a group, what happens? The number of shells is getting added and thereby the size of the atom increases. So, atomic size increases as we move down a group. Across a period, as we travel from left to right, what happens? Yes, we are moving within a shell. The shell number doesn't increase. And thereby the effective nuclear charge attracts the valence shell towards itself, and thereby there is a shrinkage in the size of the atom. What is a valence shell? The outermost shell is called as valence shell, and valence electrons are those electrons which are found in the outermost shell. Okay? So, remember the term valence shell and valence electrons. Okay? Okay, now this trend is clear for you, right? What about the second trend we discussed? It was ionization energy. For that you should know what is ionization energy. Ionization energy is the energy required for an atom to give away the electrons in the last shell, to give away the valence electrons, right? So, this energy, ionization energy, as we move down a group, it is increasing. Why? Because the number of shells is increasing and the effective nuclear charge, the attraction from the effective nuclear charge towards the valence shell is decreasing. As the distance increases, the attraction also decreases. So, it is easy for the electron in the valence shell to move away from the corresponding atom. So, ionization energy, as we move down the group, since the atomic size increases, ionization energy decreases. Very less energy is required for the electron now to jump away, right? So, what happens across a period? We are aware that as we travel across a period, we are moving within a shell, effective nuclear charge increases. Children, what is effective nuclear charge? It is the number of protons or positively charged protons present inside the nucleus. So, the effective nuclear charge increases, thereby the attraction from the nucleus towards the valence shell or the outermost shell increases, and thereby the size of the atom reduces. And now the energy is required is very high for the electron to move away from the valence shell. So ionization energy increases as we travel across a period. Today we are going to discuss the third trend, that is electronegativity. So you are already familiar with this term, right? Electronegativity is the tendency of an atom to attract the electron towards itself. What happens to electronegativity? For easy remembrance, I will tell you, ionization energy and electronegativity show the same trend. Okay? Keeping this in mind, we will discuss. As we move down the group, what happens? We will combine these two trends together. As we move down the group, atomic size increases, ionization energy decreases, and so the attraction from the nucleus towards the last shell, the outermost shell, decreases, and now electronegativity also decreases, right? Because the attraction from the nucleus towards the electron in the last shell, that is valence electron, is getting lesser. So electronegativity is also less. As we move down the group, electronegativity decreases. What happens across a period? We will combine both the trends together and explain. Okay? As we move across the period from left to right, what happens? The atomic size decreases, and so ionization energy increases, and now the attraction from the nucleus towards the valence electron is very high. So electronegativity increases as we move across the period. Okay, now we should know how to combine all these trends and give a justification. Okay, now everything is clear, I think. Electronegativity decreases as we move down a group, and electronegativity increases as we travel across a period, right? Now tell me, children, where will you find the most electronegative element? Yes, come back to the trend we explained. Electronegativity increases as we move across the period. So towards the right end of the period, you will find the most electronegative element. And which is that? Look into the periodic table and tell me. Definitely not the noble gas. Noble gas doesn't come here at all. So which is the element previous to that? Fluorine. So the fluorine is the most electronegative element in the periodic table. So all the halogens, fluorine, chlorine, bromine, iodine, are highly electronegative. Of that, fluorine is the most electronegative element. Okay, I hope you have understood. Now, along with this trend, we will discuss one more trend, which is called metallic and non-metallic character. What is a metallic character? What is the specific character of a metal? Metals, they always tend to lose electrons. So which is the atom which easily loses electron? As we know, the bigger the size of the atom, the lesser the attraction from the nucleus towards the valence shell. So it is easy for the atom, bigger atom, to give away one electron. So when does the size of the atom increase? Come on, remember what I explained here and tell me, when does the size of the atom increase? When does the atomic size increase? As we move down the group, the size of the atom increases. So what happens to metallic character? As we move down the group, the metallic character increases, and quite the opposite, as we move across the period, the metallic character decreases. So metallic character and atomic size will show the same trend. So it is clear now, all metals, they are bigger and they tend to lose electrons. Okay, let's take the example of sodium, potassium. They easily give away electrons or lose electrons because they are very good metals. Okay, they exhibit high metallic character. How about non-metallic character? Non-metallic character is quite the opposite of metallic character. Non-metallic character will always be equal to ionization energy, electronegativity and non-metals. all these three trends will exhibit the same changes. Okay, they will exhibit the same trends. So when does a non-metallic character increase and when does it decrease? We'll compare it with ionization energy and electronegativity. As we move across a period, what happens? Ionization energy increases, electronegativity increases, and thereby the non-metallic character also increases, right? So it is clear that all non-metals are found to the extreme right of the periodic table, right? And metals will be on the extreme left of the periodic table. As we move down, the metallic character increases. As we move across the period, the non-metallic character increases. What happens to non-metallic character? As we move down the group, the non-metallic character decreases, because we already know that metallic character increases. So it's quite the opposite, non-metallic character decreases. So I have explained 5 trends here. Let me recap once again all the 5 trends to make it easier for you. Okay, so what happens as we move down the group? Atomic size increases because the number of shells is getting added. Ionization energy decreases because the attraction from the nucleus towards the valence electron is decreasing. So ionization energy decreases. Electronegativity, the same like ionization energy, electronegativity also decreases as we move down the group. Metallic character, it's similar to atomic size. The metallic character increases as we move down the group because the size of the atom is increasing, ionization energy is less, electronegativity is less, so it is easy for the atom to give up the electron, so metallic character increases. How about non-metallic character? Non-metallic character decreases. Okay. Now across the period, what are the trends seen? Across the period, atomic size decreases because we are moving within a shell. Effective nuclear charge, the attraction from the nucleus towards the valence electron is more, so there is a shrinkage in the size of the atom. So atomic size decreases, ionization energy increases because of effective nuclear charge, electronegativity also increases, metallic character decreases, whereas non-metallic character, yes, it is very high, it increases as we move across the period. So I hope all these trends are very clear for you. Yes, it will be a bit confusing. Replay the video once again and collectively, try to say collectively all the trends together. When you say that, definitely you should know the justification also, you should know the reasoning also. Why is it like that? Then only you will be able to answer the questions. Okay? So we have one more small topic left out, that is metalloids. What are metalloids? Yes, metalloids are elements which exhibit the properties of both metals and non-metals. Okay, example germanium, silicon, tellurium, arsenic, antimony. These are some of the examples of metalloids. You will learn more about these metalloids, very useful elements in higher classes. Okay, so the chapter is over and there is a small tabular column. We will discuss that also and we will conclude the chapter. And look at this tabular column. Children, you can hold a pencil in your hand, and when I explain you can give a tick over it. Okay. What happens to the size of the atom? As we move down the group, it increases, and across the period it decreases. Metallic character, yes, it is same. Okay, it is synonymous to size of the atom. So metallic character also increases, across the period it decreases. Non-metallic character decreases down the group and increases across the period. Ionization energy decreases down the group and across the period it increases. Put a tick mark over that, increase or decrease. Electronegativity decreases down the group and increases across the period. So children, I have completed the chapter. We will move to let us assess. Okay. The first question, look at the first question, is a match of following triads. Who contributed these triads? Dobrina, Newlands. What was the law? Law of octaves. Classification of elements in metals and non-metals was done by Lavoisier. Modern periodic law was proposed by Henry Moseley. Shall we move to the second question? Yes, it's about finding out the group number and period number. Look at this question. Lithium, what is the atomic number? 3. Configuration 2,1. Group number is 1. Why is it 1? Because the valence electron is 1. And period number is 2 because it has 2 shells. Oxygen, atomic number 8. Configuration will be 2,6. You can note it down in the text itself. And the group number is 16. Why is it 16? Because you have to add 10 to it. 10 plus 6, 16. And what is the period number? 2, because it has got only 2 shells. Argon, 18 is the atomic number. Configuration will be 288. Okay, so the valence electron is 8. Add 10 to it, it's going to be 18th group, and it has 3 shells, so it is belongs to the third period. Calcium, 20, 2882. Group number is going to be 2 because 1 and 2 you have to write it like that itself. If it has 1 and 2 electron, if an element has 1 and 2 electron, it belongs to first group and second group. And what is the period number? 4, because it has got 4 shells. Children, we will move to the third question. Look at the third question. Yes, there are some elements given here. You have to write the electronic configuration and you have to find out the period number and group number. Do it in your file, as you know now how to find all this, isn't it? So I am not explaining this. This is assignment for you. Do it in your file. Look at the fourth question. There are 3 shells in the atom of an element X. So X is an element, okay. A fake symbol is given here. 6 electrons are present in its outermost shell. What does that mean? It means that the first shell and second shell are completely filled. So what is the configuration? 2, 8, 6. Now we will move to the first question. A. Write the electronic configuration of the element 286. What is its atomic number? You have to add 2 plus 8 plus 6. 10 plus 6, 16. In which period does this element belong? The last valence electron. How many valence electrons are there? 6 electrons. So what is the group number? You have to add 10 to it, that is 10 plus 6, 16. So in which period does this belong? It has got 3 shells, so it belongs to third period. Write the name and symbol of this element. The name will be, yes, 16, what is it? Oxygen. So oxygen, and the symbol will be O. To which family of element does this element belong to? Okay, it belongs to oxygen family, isn't it? 16th group. Draw the Bohr atom model of this element. So by now you should know how to draw the Bohr atom model. Draw it in your file. Do all the let us assess questions in the file. Okay children, we will move to the next question. Electronic configuration of element P, Q, R and S are given below. So look at the configurations. Yes, P is 22, Q is 282, R is 285 and S is 28. Which among these elements are included in the same period? Look at P. It has 2 shells, it belongs to second period. Q, it has 3 shells, so it belongs to third period. R has 3 shells, it belongs to third period. And S has 2 shells, so it belongs to second period. So we can write P and S belong to second period, Q and R belongs to third period. So answer is P and S, Q and R. Both the answers should be mentioned. Which are those included in the same group? So we have to look into the valence electrons. So P and Q are having 2 electrons, so they both belong to the second group. So the answer is P and Q. Which among them is a noble gas? Yes, tell me children. Yes, because it has 8 electrons in the outermost shell. To which group and period does the element R belong? Look at R. So the group number is 15. Why? Because it has 5 valence electrons, you have to add 10 to it. So 15, and the period number is 3, right? Because it has got 3 shells. Now we'll move to the next question. It is a very important question. Usually it comes for exam. Okay. So it is a short form of periodic table. Incomplete form of periodic table is given here. You can see that. And fake symbols are also given. Okay. Now we are going to answer the question. Which is the element with biggest atom in group 1? Look at group 1. What are the elements in group 1? A, B, C and D. Right. So these are all elements which belong to group 1. Which is the biggest element here? Now we have to apply trends here. Okay. As we move down the group, atomic size increases. So the answer is D. D is the biggest atom in group 1. Which is the element having lowest ionization energy in group 1? Which one has the lowest ionization energy? Remember the trend of ionization energy. As we move down the group, ionization energy decreases. So D is the element which has the lowest ionization energy. Which element has the smallest atom in period? Period 2. Okay. What are the elements in period 2? B, E, I, K, L, M. These are the elements which belong to group 2. So remember the trend of atomic size. As we move across the period, the size of the atom decreases. So M is the element with the smallest size, right? Which element has the smallest atom? M. Which among them are transition elements? Transition elements are the elements which belong to the middle portion of the periodic table. So G and H are transition elements. And which of the elements L and M has the lowest electronegativity? Tell me children, which has the lowest electronegativity? As we move across the period, electronegativity increases. So M is most electronegative and L has the lowest electronegativity. So the answer is L. Among B and I, which has high metallic character? Where is B and I? So you can see it belongs to second period. So B and I, metallic character. Remember the trend of metallic character, it decreases across the period. So which is most metallic, highly metallic? So which element is highly metallic? B. Which among these are included in halogen family? Look at 17th group. M and N are elements which belong to halogen family. Which is the element that resembles E the most in its properties? Find out where is E. So it belongs to second group. So we have studied in modern periodic table that all the elements that belong to the same group exhibit similar properties. So what is there beneath E? F is seen beneath E. So F is the element which shows similarities to E. Okay. So our chapter is over. I think you have understood the periodic table chapter clearly because it has got more content in it. So any part, if you have any doubt, just replay the video and watch it once more. And if your doubt persists, you can always call me children, clear your doubts, because this is the basic of chemistry. Okay. Latest assess has to be written in files and send the files as early as possible. Okay. Bye children. Meet you with a new chapter the next video session. Take care. Bye.